Hi everyone, welcome back to workshop, and the lathe project is now complete. As you can see, I've now got the stand installed with the drip tray fitted, and of course the actual lathe itself mounted onto the stand, and it's all looking pretty good. So let's go over and I'll run you through exactly what I've done. And the first thing is the actual stand itself. As you can see, it's blue. It's not my favourite colour in the world, but I really struggled to find even a second-hand one on eBay. So I found this one brand new, and it's just the right size for the lathe. Blue, who cares? And it's got two nice pillars there, which act as storage cupboards effectively. Didn't come with a lathe bed, didn't come with the actual drip tray, so I actually got this one made up to my own specifications, to my own size. Again, I couldn't find a tray to the exact, sort of dimensions that I wanted. Well, I found one that was long enough and deep enough, but it was quite chamfered at the corners there, which didn't really match with the corners of the posts there. I really needed something as square as you can see there. So one of the companies on eBay that was selling bespoke trays said, yeah, no problem, just give me your sizes and we'll make something up. So I did that, and they even painted it for me. So got that yesterday, so managed to get everything installed yesterday and get it all up and running. And then on to the actual lathe itself. As you saw in the last video, I was cleaning it up and painting it and all the rest of it, so there wasn't much extra to do there. I just had to work on the actual control panel. As per my last video, I was changing the drive, the motor, to a variable speed control. So as you can see, the motor's down the back there, but we'll come to that in a minute. As you can see, I've made up a nice little control panel here, just an aluminium enclosure that basically just bolts onto the front of the lathe there, over the top of the label that used to be there. And I've got a run stop, speed control, and of course the obligatory emergency stop push button, just in case anything should happen. So as you can see, there's a control cable here that's glanded into the bottom of the box there. That goes away off and round, and actually this is it coming down here with the power to the actual motor there. They've come together and they go away down and in through the side there of the housing there. And whilst I'm down here, I've got a nice on-off switch there for the AC power coming in. So let's open it up here, and this is where my motor driver board and the power supply go. It's not bolted in at the moment. I'm still playing about with this really. I want to make sure it's reliable, etc., before I actually mount it up onto the side of the pillar there. But for the moment it's going to be fine in there. It's a fully sealed inside there, so it's not as if anything can land on top of the electronics. So I've got the AC power coming in, I've got the DC output to the motor, and obviously the control signal coming in here from the panel on the lathe. And of course it's fused as well. I've got the power to the motor driver board's fused, and I've also fused the the 24 volts that goes up to the control electronics up top. Now I have mounted the motor control board onto the top of the power supply. However, I have put in a 1/4 inch thick aluminium sheet between the two, just for any kind of thermal issues that I might have. However, I have been running the lathe not fully under load, but certainly at full speed with a bit of a load, and the heat sinks on the motor control board and the power supply are basically stone cold. So it looks like it's spec'd up properly there, and I shouldn't have any issues. What else have I done? I've put a stainless steel sheet backdrop there, just to stop any hot shavings or anything like that hitting the sides of the workshop there. A couple of brackets there and a nice solid shelf there. And if you look down the back there, there's no way any filings or shavings can go down behind the lathe. It's sealed along the back there, and in fact the drip tray is actually bolted to the stainless steel plate, so it's well in place there. So let's power her up, and we'll go down onto the main switch here. and that's signified. I've got a green LED there. That just means I've got 24 volts. I'm in the stop position. Speed control doesn't really matter where that is. And let's turn it on, and I'll vary the speed. It will actually run real slow, although what use that would be on a lathe I don't know. As I said before, I don't know that much about lathes. You know, this is new for me, so whether I'll make use of a slow speed like that, I don't know. But certainly it seems to be fast enough at maximum RPM. I think I'm getting about 850 RPM full speed, and from what I can see on the net, on YouTube, the people are using lathes and doing a bit of turning and that sort of thing. You know, 800, 1000 RPM seems to be a good number. So I think I've hit it quite lucky that I'm managing to get 800 full speed. So what I have done since I first started testing, I actually did change the motor. I was using a wheelchair motor on here before, which had a completely different ratio, a different drive pulley there, and it was using a different pulley up at the top there. And I was getting about 2000 RPM on the chuck at the top there, but there was no torque below 1000 RPM or 500 RPM. There was just no torque at all, and it was easy to stall the motor. So I then realised that I didn't have the right ratios here, so I did actually, as per my last video, changed out the motor there, and I've got this one up and running. Funnily enough, I had to extend the shaft of this motor here, and I did that by turning a brass extension here on the lathe itself. Funnily enough, I still had the old motor hooked up. What I did was I managed to, a bit of brass stock here, round bar brass stock, I had to drill out a 10mm hole. It's about, oh, I don't know, 14mm, 13mm in diameter, and I had to drill a 10mm diameter hole about 3/4 of an inch down inside that brass shaft. There was no way I was going to do that with my pedestal drill, not accurately enough, so I managed to do it on the lathe actually, and then that 10mm hole, it sleeves over the top of the original shaft on the DC motor, which is only about ½ an inch long there. So that I was able to do that, and also put on a rope in right through to lock that into place. And then this end here is an interference fit over the top of the brass stock at this end. However, I did drill a 4mm hole all the way through the brass stock into the motor shaft itself, and I've tapped the end of the motor shaft, so that allowed me to put in a threaded bar right down the middle there, and put a nut on the end and just help lock that in place. If it does slip later on, I can always put a rope in through, but for now I think it's going to be okay. It's quite tight. So what that's done is given me a much better gearing, a much lower speed RPM on the chuck itself, and enabled me to keep the torque right up there. So I've put a little guard in place just in case any sleeves or oily rags or anything like that get caught up. Just a little bit of safety first there. So here's up and running again, and I'll just show you the plastic gears here for driving this auxiliary shaft down there is working as well. So I'll just stop it there and engage that plastic gears there, and that'll allow me to, and then I'll just engage it there. That's it, and then start it up again. Now, as you can see, this is turning as the bed moves along. The plastic gears, I've got a whole load of them, so I can change the gearing on them to give me a different speed, a different ratio for the horizontal movement of this compared to the motor RPM. But I've kind of put the lowest gear on possible, so that this moves at its slowest, because I think mostly I'm going to use that just to help automate the turning along the axis there of anything you know, I'm machining down. Rather than turning this handle by hand, I can just automate that just by you know, using this auxiliary shaft here. So what else I'll use it for, I don't know, but that's how I foresee it happening anyway. So I have got a cutting tip installed. I bought some new carbide tips there, the replaceable tips there, and I've got a little box of them up top here on the shelf. I just got these via eBay. The carbide tips are apparently the hardest tips or something like that. And I have actually got some other bits and pieces that I got with the lathe. I'll find out what these do in the fullness of time. And I've also got these tools here that I got with the lathe as well. These are used, well, most of them are used. They look like they've been sharpened once upon a time by the previous owner, so I'll see what they do. And then the right hand pillar here is just storage. Got a spare belt for the lathe, the plastic gears here for the auxiliary shaft there, and that's about it in there. And the old pulley for the motor, and an old guard, I don't need that. So that's it. Hope you enjoyed this little project, and hopefully the next one I'll get on to some real electronics, but it was good fun going through the restoration of this old lathe and getting it up and running in the workshop. Thanks for watching.